Hello. Welcome to Sky Sea channel that always presents interesting and informative content about the sea and life in it. This time, we will discuss how the sea can be a source of electricity that is environmentally friendly and sustainable to overcome the energy crisis that threatens the world. As we know, electricity is one of the basic needs of human beings in this modern era. Without electricity, we cannot carry out various daily activities, such as transportation, communication, industry, and entertainment. However, most of the electricity we use today comes from non-renewable sources, such as oil, coal, and natural gas. These sources are not only limited and expensive, but also cause negative impacts on the environment, such as global warming, climate change, and air pollution. According to data from the International Energy Agency, the energy sector was responsible for about 76% of global greenhouse gas emissions in 2019. So, what is the solution? Is there another source of electricity that can meet our needs without damaging the environment? The answer is yes. And the source of electricity is in the sea. The sea is one of the largest and widest sources of electricity on Earth. The sea covers about 70% of the Earth's surface and stores a large amount of energy in various forms, such as waves, currents, tides, salinity gradients, and temperature differences. These energies can be used to generate electricity using certain technologies. According to estimates from IEA, the global potential of ocean energy reaches 20,000 to 80,000 terawatt-hours per year, which is equivalent to 10 to 40% of global electricity consumption in 2018. Let's discuss them one by one. First, there is wave energy. Waves are the up and down movement of the sea surface caused by wind. Wave energy can be captured by devices called wave converters. There are various types of wave converters, such as oscillating water columns that trap air to drive turbines, floating body converters that use wave motion, and overtopping converters that utilize height differences. According to data from the World Energy Council, WEC, the global potential of wave energy ranges from 8,000 to 80,000 terawatt-hours per year. Second, there is tidal energy. Tides are the rise and fall of the sea level due to the gravitational pull of the moon and sun. Tidal energy can be produced using several technologies, such as dams or barrages that control water flow between high and low tides. Tidal or tidal current turbines that are installed in areas with strong currents, or hybrid applications. According to data from WEC, the global potential of tidal energy is more than 300 terawatt-hours per year. Third, there is ocean current energy. Ocean currents are large-scale movements of seawater caused by differences in temperature, salinity, salt content, depth, and Earth rotation. Ocean current energy can be utilized using ocean current or river current turbines that are installed in areas with fast ocean currents. According to data from WEC, the global potential of ocean current energy is more than 800 terawatt-hours per year. Fourth, there is salinity gradient energy. Salinity gradient is the difference in salt content between seawater and freshwater. Salinity gradient energy can be generated using several methods, such as pressure-retarded osmosis that utilizes freshwater flow through a membrane to increase pressure in a saltwater tank, or reverse electrodialysis that utilizes salt ions that pass through alternating tanks of saltwater and freshwater. According to data from IEA, the global potential of salinity gradient energy is about 2,000 terawatt-hours per year. Fifth, there is ocean thermal energy conversion. Thermal gradient is the difference in heat between warm seawater on the surface and cold seawater at a depth of 800 to 1,000 meters. Thermal gradient energy can be utilized using ocean thermal energy conversion technology, which uses this temperature difference to evaporate a low-potential liquid, such as ammonia, and condense it back to drive a turbine. According to data from IEA, the global potential of thermal gradient energy is about 10,000 terawatt-hours per year. Well, those are the 5 forms of ocean energy that we can use to generate electricity. So, what are the advantages and challenges of using this ocean energy? The advantages of ocean energy are, first, ocean energy is a renewable source of electricity, meaning it will not run out and can be naturally restored. Second, Ocean energy is a clean source of electricity, meaning it does not produce greenhouse gas emissions or hazardous waste that can damage the environment. Third, ocean energy is a widely available source of electricity, meaning it can be found in almost all coastal regions in the world. Fourth, ocean energy is a predictable source of electricity, meaning it can be accurately known when and how much electricity can be generated. The challenges of ocean energy are: first, ocean energy is an expensive source of electricity, meaning it requires high costs for construction, operation, and maintenance of infrastructure and equipment. Second, ocean energy is an immature source of electricity, meaning it still requires further research and development to improve the efficiency and performance of the technologies used. Third, ocean energy is a potentially negative source of electricity, meaning it can disrupt marine ecosystems, fishing activities, shipping, tourism, and national security. Are there any countries or companies that already use ocean energy? The answer is yes. Some examples are: first, in Scotland, Orbital Marine Power operates the world's largest tidal turbine that can generate electricity for 2,000 homes every year. The turbine has a length of 74 meters and a weight of 680 tons, with two wings each having a rotor with a diameter of 20 meters. The turbine generates 2 megawatts (MW) of electricity and requires an investment of about £7 million. Second, in France, Sabella develops tidal current turbines that are installed in the Fromber Strait and provide electricity for the island of Ushant. The turbine has a diameter of 15 meters and a weight of 450 tons, with a power capacity of 1 megawatt. The turbine requires an investment of about €10 million. Third, in Australia, Carnegie Clean Energy tests the Cedo 6 wave converter that is connected to the national grid. The converter has a diameter of 20 meters and a weight of 240 tons, with a power capacity of 1 megawatt. The converter requires an investment of about $11 million. Fourth, in Norway, Statkraft built the world's first pressure-retarded osmosis power plant that uses salinity gradient energy. The plant has a power capacity of 4 kilowatts (kW) and requires an investment of about 20 million Norwegian kroner. Fifth, in Hawaii, Mackay Ocean Engineering built the first ocean thermal energy conversion power plant in the United States that uses thermal gradient energy. The plant has a power capacity of 100 kilowatts and requires an investment of about $5 million. That's our explanation of how the sea can be a source of electricity that is environmentally friendly and sustainable to overcome the energy crisis that threatens the world. We hope this content is useful and adds to your insight. Don't forget to like, comment, share, and subscribe to our channel so you don't miss other interesting content about the sea and life in it. Thank you for watching and see you in the next video.